Okay, so for today's notes, we're going to be picking up where we left off yesterday with our prisms and cylinders. So yesterday we learned how to find their lateral area and surface area. Today we're going to talk about how we can find the volume of these two types of figures. So the first thing we're going to write down is our formulas. So for my first formula, I'm going to have volume is equal to base area times height. And the capital B, remember, stands for what? Base what? Yeah. And the H stands for the height. So the capital B means we're finding the area of our base, while the H is the height of the figure. And remember, our height has to be perpendicular to wherever our base is. So make sure that they say that it's a right or it appears to be a right. If it's an oblique, which is the slanted ones, that outer edge cannot be our height, right? Okay, for our volume of a cylinder, it's pretty much the exact same formula, but in a cylinder, we know that our base will always be what shape? A circle. So we can replace that capital B with our formula for area of a circle, which is pi r squared. So pretty much the exact same formula, just replacing it for our circle. Again, B representing our base, which we know is always going to be a circle, where H is representing the height. And again, our height has to be perpendicular to our base. So if it's an oblique cylinder or an oblique prism, we might have to find the height, right? Okay. So we've got our formulas. They're pretty much the same formula. We just change it out depending on what kind of shape our base is. So now we're going to look at the first example so we can apply these formulas. So the first example they give us is this right trapezoidal prism. So they did specify that it's a right. So that means this truly is the height. We don't have to find anything. It's not oblique. It's not slanted. So our formula is volume equals what? Base area times height. And what kind of shape is our base here? Trapezoid. Can anybody tell me what our formula was for area of a trapezoid?
1/2 base 1 plus base 2
times the height. Right. And they actually gave us a base 1 and a base 2, right? They said the longer base was 14 and that this shorter base is 6. And they gave us the height of the trapezoid. They said that was 3. And they gave us the height of the entire three-dimensional figure. So all we have to do is plug all that into the formula. So we've got our formula here. Like you guys said, this would be what all we're plugging in. So we have our height in our trapezoid, and then the height that we're multiplying for the volume formula is the height of the prism. So those are two different heights, right? So in the formula, I've noted that this with a subscript P is representing the height of the prism. And since they gave us numbers for all of that, we don't have to find any pieces. We just plug it all in and simplify. So we've got our 1/2 times our base 1 plus base 2. They said base 1 was 14, and since our bases are congruent, if this edge is 6, then this edge is 6, right? And then they gave us the height of the trapezoid to be 3, and then the height of the prism to be 5. So first I simplified inside my bracket. So order of operations says we would do what first? Yes, add inside my parentheses. So that would give us 20. And then we multiply inside of the bracket, right? The 1/2 times the 20 times the 3, which would give us 30. Good. And then I can multiply my 30 times that height, right? So we end up with a volume of, nice. All right, for our second example over here, they gave us a right cylinder. Again, they said it was right, so that means that the piece they have marked as the height actually is the height. We aren't going to have to find it. Okay, so it's the same formula, volume equals base area times height, but in a cylinder, our base is always a what? Circle. So we can go ahead and replace that capital B with what we know the area of a circle is, which is pi r squared. Do we know the radius? Yeah. They gave us radius, yes, and they gave us the height, so I just substitute all that information in. Order of operations says I will do what first? The exponent. So square your 9 first, and then you can go through and multiply your 81 and your 6. So our exact area would be what? Very good. And then we can actually multiply it by pi to get our estimate answer, which would be approximately 1526.814. All right, so here were 2 examples where they gave us all the information we would need. All we had to do was plug it all into the formulas. Let's look at another example. So here, they say that the volume of this cube is 90. So this time they gave us the volume. They want us to find the value of x. Okay, well in this picture here, for x, if this is a cube, every single one of those sides should be what? The same. Yeah, so that's why we can use the same variable to represent the length, the width, or the base, and the height, and then the actual height, right? Okay, so our formula is normally base area times height. Well, our base is what kind of a shape here? A square, and how do you find area of a square? Side squared. Okay, so our base area would be side squared times the height, which is also the same side. So x squared times x would be x cubed. So here, whenever we plug in what we were given for our volume formula, we should have that our base area times height really is just represented by x cubed. Okay, and they did tell us what our volume was. They said it was 90. So, just like to get rid of a square, we take the square root. To get rid of a cube, you would have to take a cube root, right? And our calculator has a function for that. So if you will press the little button that says math, it brings up a list of options. Choose number 4. And then you can type your 90 under that cubed root, and it'll find the cubed root for you. So it doesn't have a perfect cube root, right? It's a decimal. Approximately, what are we going to get there? Good. So our exact side length would have been the cubed root of 90, but our estimate would be this decimal value. All right. Let's look at another example. So on this next one, it says to find the volume of this oblique cylinder. So they did mention that it's oblique, meaning that the side edge could not be its height. But did they give us the actual height? Yes, they did give us the actual height. So we aren't going to have to find it. So I'm just going to plug everything into our formula. So our formula is base area times height, or since it's a cylinder, pi r squared times height. Where we said they gave us height, did they give us the radius? Yeah. So we just plug all of that information in. So when I go to simplify, what am I going to do first? The square, right. So I square the 4, and then I can multiply by the 7. So what would our exact volume be? 112, good. So we got 112 pi. And then when we actually multiply by pi, that'll give us our estimate of 351.858. All right, and then we got one example left on the back. So for this last example, they want us to find the base area to then use to find the volume. So what's our formula for volume of our cylinder again?
I r squared.
Very good. So we need an R and we need a height. Did they give us the height? Yes. They said the height was 5. Did they give us R? No. Okay. So that means we're going to have to find R. So do we have any idea how many degrees the angles are in that right triangle? Right, we just know it's a right triangle, but we don't know how many degrees, right? So we can't say for sure. What we do know is that this is a right triangle in which from the center to here is what we would refer to as the radius. And from the center to here, what we would refer to as the radius. And if it's the radius of the circle, it should be what? Equal, right? So what could we maybe set up to solve for R?
45, 45.
Yeah, it is going to be a 45, 45, 90. Also, we can say that because we know that those two pieces are congruent, you actually could also do Pythagorean theorem because you're really only solving for one variable still, right? So either one is fine. I know you guys are really familiar with 45, 45, 90, so maybe we'll go about solving it with the Pythagorean theorem to change things up a little. But we'd have r squared plus r squared, since those are our two a and b sides, equals the 3 square root of 2 squared. So over here on the left, I can combine those r squareds, right? R squared and r squared would give us 2r squared. And over here, when I square 3 square root of 2, remember that literally means 3 square root of 2 times 3 square root of 2. So what would that give us? So 3 square root of 2 times 3 square root of 2. 3 times 3 is 9. And square root of 2 times square root of 2 is... So really, it's going to give us 18. Good. All right. So then we want to solve for r. So what would we do next? Divide by 2. Good. So then we have r squared equals 9. And then what do we do to get rid of that square? Take the square root. So r must be 3. All right, so now that I know r, can we find the base area? Yeah, just pi r squared, right? So what's our exact base area going to be? 9 pi. All right, and then when they ask for the volume, we're going to need to plug in that base area. What am I going to multiply my base area by? 5. Good. So my exact volume should be... Good. And then we can actually multiply it by pi to get our estimate answer of 141.372. So the volume is typically a little bit easier than the area just because there's less pieces you're having to find altogether.